All right, so for this question, we first notice parentheses, and those parentheses indicate to us that we need to use our chain rule. So because we have parentheses here, this is going to be our inner function. So we'll focus first on taking the derivative of the outer. The derivative of tangent becomes secant squared. We keep the inner fixed at parentheses 3 theta squared. Then we have to multiply by the derivative of the inner. And here the inner is 3 theta quantity squared. So there's two ways of doing this problem. You could distribute first, and then after you distribute, you could take the derivative. Or you could use the general power rule here because we have parentheses to a number. So if I use the general power rule to take the derivative of the inner, I'll bring down the 2, keep the inside fixed, subtract 1, so I get 2 minus 1, so I get 1, times the derivative of what's inside the parentheses. So the derivative of 3 theta would simply be 3. Now remember that something in the front, something in the end, those two usually are going to combine together. So we multiply the 2 times 3 to get 6 times 3 theta to the first power. Now, you don't want to leave it like that. And again, we're kind of going off to the side here and just focusing on how do we find the derivative of this inner function. But you don't want to leave it as 6 parentheses 3 theta to the first power because, again, that first power is unnecessary. It's understood. And so you can just multiply the 6 times 3, get 18 theta, and that is your derivative of your inner function. So all of this work was the derivative of the inner. We bring the dot down, and then we bring all of our outer derivative down. So secant squared theta, and then 3 theta quantity squared. And so then what we would want to do is move the coefficient, put the trig at the end. So we could rewrite that as 18 theta, and then secant squared 3 theta quantity squared. One thing that I do want to mention just really quickly is that you could go through it this way, or if you wanted to, you could simplify first. And there is a simplification that happens here. You could go inside of those parentheses and distribute this 2 to the 3 and to the theta. And so then you could rewrite the problem as secant squared of 9 theta squared. And if that's easier for you to work with, that would be fine, because what would happen in that case is that you would take, not secant squared theta, but tangent of 9 theta squared, because then what you would do is you take the derivative of tangent, that would give you secant squared, keep the inner fixed, and then multiply by the derivative of the inner, which would be your 18 theta. So in this case, I think simplifying first would probably be easier, but if it doesn't ring true to you at the beginning to simplify, you will still get the same answer.